Hi there. In the previous talk, you could find out how you can use profiler-based optimizations to make better MySQL binaries. I'm going to talk how you can use profilers in production to find out what's going on with your MySQL production server. Mostly about that. So I was working with MySQL for almost 11 years already in all kinds of companies that provides public support. The experience I've got from there is interesting. In MySQL.mp4, Sun and Oracle, I was a member of bugs verification team. So as a result, I had to deal with MySQL mostly as a problem, not a solution. After that, I tend to think and speak about MySQL in terms of bugs. So you will see a lot of bug numbers. Whenever bug number or anything is highlighted on these slides, it's a reference. You can click on the PDF slides or whatever and end up looking at the details. At Percona, where I worked for 3.5 years, Percona is a solution-oriented company. So there I try to think about MySQL as something that can be used with all its limitations and bugs to solve a specific problem. So that helped a lot. Finally, now in MariaDB, I have to deal with a wider range of customers, kinds of MySQL and use cases than ever before. So that's what's important. And also starting from Percona, I'm now writing in public about MySQL and I'm speaking about MySQL. Of all the conferences, I like FOSDEM most than anyone because it's packed of content. Let's hope I will keep it that way as well. So I would like to speak about profilers, specifically about profilers on Linux, and only 3 of them. Historically, the oldest probably and widely applied to MySQL in the past, OProfile, just to thank the developers and people who used it in the past. No talk about profiling MySQL can end up not mentioning Domas Mituzas and his poor man's profiler, so I will mention it, even though you may consider it unsafe to use it in production, and in some cases you may hit a problem that I will quickly mention and how to resolve the problem, how to notice it. And the last but not the least, recently, if you would like to profile MySQL, you have to use perf. And you've seen an example how it's used to get better binaries. I will show a couple of examples how you can use it to find out what's really going on alive. We will also get a slide about the performance impact of using profilers in production, because you need to know it's safe. Your measurement or your performance monitoring should not be a performance problem by itself. It's not easy, but with perf it's kind of possible. What I will not speak about is all kinds of good profilers for memory, for calls and everything that requires rebuilding of MySQL, because not everybody like Dropbox can afford to spend days building proper binaries for their specific load, and it's a hard task. We will use, in most cases, just vanilla binaries from some vendors or something you build once for yourself and then use for years. So this rules out gprof, this rules out running under Valgrind and all the other things. There are also great operating system tools to get insights what's going on in any process like systemtab, or historically that's now also available in Linux, dtrace. I'm just not good at them, so that's why they are out of consideration. What's also out of consideration is performance schema, and that might be an interesting question. Why? I will tell. First of all, in production, you may hit cases when performance schema is not there when you need it. For example, MySQL from Facebook, storage engine, that's very of a high interest. They just built their MySQL without performance schema. MariaDB, we do include performance schema, but it's not enabled by default. So in production, you cannot effort restarting your MySQL in many cases just to get more monitoring insights. Okay, next time you restart it, you will put it there, but it may be not there at the moment. Another thing, unfortunately, performance schema is getting more dynamic and more detailed, and it's lightweight instrumentation comparing to anything else with each release. But unfortunately, still there are instruments that must be enabled at startup then they can be disabled later to be so that you can enable them selectively when you need them. You may find out that the instrument you need for your specific load was not enabled initially, and then you still need a restart. Another problem with performance schema, it stores data in memory, in cycle buffers. The size of these buffers is predetermined at startup, at least in GA versions of MySQL. So if it was too small, you will find out, but it's too late, you again have to restart. So performance schema data may not be there. Another problem that some of the plugins or third-party storage engines may just do not have instrumentation. Mark Leith will speak about how to do it properly, but not everybody does it. Again, MyRocks does not have this instrumentation. I am not sure if any of vendors like Percona or MariaDB who is working on implementations of it will put the performance schema there at all. So you should be ready for that. And surely a lot of people also speaking about performance schema all the time. What's interesting for me in this regard is that, unfortunately, based on some cases I've studied for this talk and I had to deal with over last year, I see that performance schema may just not provide enough details. I will use a very stupid example from one of the oldest bugs, where I spent time making MySQL run faster on IX and PowerPC many years ago. But this is a great example. So when this simple select benchmark 500 million times from something works like for dozens of seconds, everything in these MySQL binaries will be slow. Replication will be slow because single thread performance matters. So it's an interesting bug by itself. But what would you see, for example, if you would try to use performance schema to kind of optimize or check how your better optimized binary work? All you will see is at the right. You will see that you spent 13 seconds plus something in executing, and that's all you will get. Even in a very simple profiler call, this output is from perf, you can find out specific functions, because profiler instrument things per function. In any case, where the time was spent. No wonder it was spent in multiplication and in benchmark function call. But the share of time spent, it may differ with rebuilding, and in more complex cases, you get an insight that you just cannot get from performance schema in any way. So it doesn't provide enough information. Now, let's get back to real production issue. Some of you probably were present at the pre-FOSDEM day yesterday, when Sveta Smirnova told that one of the most strange stages of query execution is called statistics. So the query may spend a lot of time in statistics stage, and you may not know why. I've got it in real life. Like for 3 months, I am working on a complicated case where this is one of the problems we see. Simple query, it's a single line select by primary key from one table that is not accessed by anything but this select at the moment, so there is no kind of read view locking, but in a high concurrent environment. Sometimes spend seconds, many seconds, and even minutes in statistics stage. And what you can get from performance schema, even from very advanced query, that, well, there is a statistics stage. I do not see weights behind that, even though I expected them. It may be for many reasons. One of them, that when you really query the performance schema data, you query on a live system. It may be a few seconds later, and all the weights, even if some of them were there, they may be gone already from the buffer. So they were not lost, but they may be gone. Or maybe the query is wrong. You would never find out. So, but what you would find out? You would find out a lot more with profilers. This slide with the links is just a history of applying OProfile to MySQL. OProfile is available since 2001 or so. It's initially based on sampling by timer, so it adds overhead, but still there were a lot of problems in MySQL found out, like all that scalability issues of table cache that were resolved mostly since 5.5 with introduction of metadata logs and all that kind of stuff. So just check all the details. There are many more, like probably 20 bugs that I picked up for my blog post that is already published, and you can find it and get more insights. So good people, well-known engineers like those who now work for Facebook, historically, like 10 years ago, were already spending time profiling MySQL and proving where is the problem with OProfile at that moment. So OProfile is actually easy to use, but you should know there are two kinds of OProfile. OProfile till version 1.0, old one, based on a separate daemon that is started and polling events by timer, collecting them, and then you can process them. And then creators of OProfile, after perf appeared and successfully used like CPU instrumentations, were able to get a lightweight profiling. So they kind of rewritten their OProfile, provided different binaries. So version starting from 1.0 just work differently. The op control binary is gone, the daemon is gone, and OPerf binary is introduced. So if you are going to use it, and you will have to use it depending on the kernel, because all that access to processor counters and everything is available only starting from kernel 2.6 something. So if you are using, maybe for whatever reason, Red Hat Enterprise Linux 5, you are out of options but OProfile. That's why probably you still should know it. So you need it, you start it. If you do not need, and probably for MySQL you do not need to profile kernel calls, you put no VM Linux there. So the data is collected. When the data collection is not needed anymore, you stop it, then you dump it, and then you run the report. This set of actions was so widely used that Percona embedded it into ptstock tool as a separate option collector profile. It kind of works, so I was able to use it, not without the, not at the very first case. So it's not always clear why the data are not collected. There may be several problems. The daemon may be not there, the version may be different, the command may not work, so it's not very wordy about it. And not all set of options produce OProfile results, but you can get it. So what changed? Now if you will take, for example, Fedora 25, you will see a new OProfile there. You install the same package, but commands do not work. So ptstock will not produce your profiles at all because op control is gone. So currently, in these versions, OProfile runs more or less like OPerf. So you start data collection with OPerf, then you stop it by sending signal, or if it's in foreground by pressing Ctrl+C, and OPreport command is still the same. What I should say after trying OPerf, OPerf theoretically allows to run under OPerf single binary, and you can do it not as a super user. But if you will just try to pass the process ID of MySQL server to OPerf and try to get the results on a multi-threading system, you will get the results only for on multiple core systems. You will get the results from only one core. I'm not sure how it's picked up, like the one where the OPerf itself works, but it's just one core, so it misses things. That's why I suggest to use system-wide profiling with OPerf as well, and it's now embedded as one of the pull requests to ptstock, so that ptstock continues to use OProfile when available, like on Fedora 25. Let's see if it's implemented in this way or that, but it's just a warning for you. So if you have multiple CPUs or multiple cores, please use OPerf with system-wide profile, otherwise you may come up with wrong conclusions. So this is how it works, this is what you get. The same stupid example as before, with a benchmark and multiplication. What's interesting here, you get a number of samples, so how many times this function call was noted, and the kind of overhead, percentage of time spent in all these calls. Sometimes these numbers do not correlate, so you may have a very hard call. So another thing, poor man's profiler. So Domas invented it kind of around 2007 or 2008, I don't remember. And what's great about it? In a lot of cases, you do not need the power of a real profiler. All you need to know is where your threads are now hanging. And you can get it with PTPMP in original poor man profile really easily. Behind the scenes, historically it used GDB, so you trace your binary, and after running it may be left in traced state. So please take care, and after running PMP, check if your MySQL is running. If it's hanging, send continue a signal to it to release it, if you are going to do it in production. Otherwise, you have services stop. And another couple of things, there are ways to make PTPMP less impacting the performance. There is a quick stack that may be used instead of GDB, and there are some command line options for GDB that can be changed in the code. The bug is not fixed by Percona, it just hangs around. So in PTP.mp you may find out that, for example, with that statistic state, one of the cases that I reported, actually we are waiting, sleeping, and trying to enter the InnoDB QE. Why? Because we were running with a limited concurrency. So we had many long-running threads that were all busy, and our statistic state, while jumping into the statistics, trying to access index to find out how many rows it will get one row. It's stupid, but this is how MySQL works. It's just like diving into the index trying to find out, and it hangs there because it cannot get the results from InnoDB. If you do the same select from other MyISAM table, it works instantly. But in InnoDB it hangs, and already poor man's profiler allows to do that. Is it always useful? No. If we apply it to case of benchmark, we will see, okay, we had one occasion of this long stack thread. Okay, we see how things are called, but what does it give us? We do not know how much time was spent in each specific call. That's it. And we do not see anything special like we are hanging on some mutex or lock, so it's a kind of useless. What's useful in this regard is perf. So you will see some success stories. Here I've collected bugs, just some of them, like half of them, still active mostly, reported by one single guy, Mark Algan from Facebook. You can find a lot of more of good usage examples of perf. So basically perf works with two commands. Perf record, you need it to record the perf data, and perf, then you stop it, and then you analyze the data with perf report. So here it is. Different command lines are explained in my blog. Probably you need to send SIGINT signal. Probably you also need to always use -a system-wide profiling, so that you will see where time is spent from the operating system level as well. And otherwise you again may get wrong profiling data as with OPERF, just from one core. With OPERF and with perf you can get not only flat outputs, but you can get a hierarchy, a tree of calls with detailed information where the time is spent and everything. Speaking about which profiler to use this day, I'll tell you just a result. Use perf, if you can. If you are on older Red Hat, you have to use a profile. Why is that so? Because of the performance impact, and I will show it on my last slide. So in case of applying perf to that statistics problem, we see that actually we really try to get statistics by diving into the index, and we cannot do it because MySQL is busy at InnoDB level. So it's like a stupid to create a plan that is simple, use primary key. We spend time trying to get information, and we do select the data to find out how to select the data. Sorry about that. But, well, the problem in that case was limited concurrency, but that's not the only possible reason of hanging in statistic state. So I'm still like work in progress on that. The last but not the least, one example of when you have to use profilers because there is just no performance scheme. I try to profile MyRock specific load that is questionable and everything. There is a query, historically from older InnoDB bug, that can be executed differently, different join order, and one of the queries avoiding file sort, that is normally a desirable thing, but another does file sort. And it turned out that queries, in my case, in my specific case that is explained in details in the blog post, that the query with file sort actually a bit faster and scales better with the number of threads. Like I tried on 4 cores up to 64 threads, and the gap is visible. And it's interesting what happens at 4 to 8 threads, because the gap is growing, specifically in MyRocks. So I tried to apply it, to apply profiler to that, and found out that in case of file sort avoided, we have like mutex logs where notable time is spent. So somehow at this concurrency we have a problem with concurrent access to some internal structures of MyRocks. So this is kind of information you can get from profilers. Also you see that different time was spent for specific MyRocks and RocksDB functions. That may also give you some hint. About performance impact, like one of the final slides. So I run that same stupid benchmark test under different kind of profilers, and what you see here, PTPMP, it gives like maybe 60 to 70% drop down in performance, so the huge impact. OPERF of all kinds, even recent OPERF, it's from Fedora 25, still gives notable performance impact. And if you will go here, you will see that perf without recording call trees gives a very minimal, like several percent of overhead, comparable to what you can usually get from performance schema. But with all system-wide profile, you get insights not only into MySQL code, but in all the kinds of operating system code. In my case, for example, I found out that most of the time is spent on HDD that is encrypted on encryption functions on some loads. So you cannot get this insight other than profilers. Thank you very much. My time is gone. Finally, because I was from bugs team, I still tell you, please report bugs whenever you see them. So here's a photo of my wife found a praying mantis and she reported it. You should do the same for MySQL, MariaDB, and Percode. Questions? I am around. Go for it, click on the links, find out. There is a lot of stuff behind that.
Thank you very much. This was good.